Hey everyone, so this is my first tech video. I've been wanting to start sharing content for a while, and today I'm just going to jump in and show you a issue we debugged at work this week. A brief introduction about me. I am a platform engineer who develop and manage a multi-tenant Kubernetes platform for our enterprise customers. So the issue what we have faced last week in our non-prod environments was we were seeing like our capsule proxy pods constantly restarting due to a leader election timeouts. Now, if you're not familiar with capsule, if I put it a very simpler way, it is a multi-tenant operator for Kubernetes. Basically, what it does is it lets you carve a single Kubernetes cluster into multiple isolated tenants without having to spin up separate clusters for each team or customer. The capsule proxy component is crucial here as it sits between your cluster tenants and the Kubernetes API server, which acting as like an intelligent middleman. We can technically it acts as a reverse proxy to the API server. So imagine when a tenant tries to list resources across namespaces. Say, like he typed, he wants to run kubectl get pods all namespaces. Normally, Kubernetes would either show them everything or nothing based on what permissions he has got. But capsule proxy, when the cluster would have the capsule proxy, it intercepts that call and dynamically filters the results to only show resources that tenant is allowed to see. Basically, it's kind of enforcing tenant boundaries at the API level, which is way more flexible than doing with RBAC for hundreds of namespaces. So back to our problem. Uh, our problem was the capsule proxy pods were uh, crashing and restarting constantly actually, because the reason was they couldn't complete their leader election. Uh, it has got multiple replicas which needed to coordinate to decide which one is active, and those API calls to establish leadership were timing out. So it took us a bit to figure out, but fix was actually pretty simple. Uh, we had to use Kubernetes flow schemas to prioritize just the API calls that were timing out. I'm going to walk you through the debugging process. Let's get into it. I have a setup of a AWS EKS cluster which already has the capsule proxy running, and if you can see, uh, our capsule controller manager were restarted multiple times. So let's look at the logs what and see what it says. It's already there. The previous meaning it gets the logs of the uh, pod which has already died. So the logs convey something here. One is it tries to reach out to API server, but it failed. It couldn't. There are two parts here. One, the timeout is pretty low. It's 5 seconds. We try to check in the Helm chart uh, if they allow us to bump up the timeout seconds, but there is nothing in the Helm chart. It looks like it has been hard coded in the code, so we couldn't go in that path. We had a similar pattern with our Kyverno, which is our policy enforcement component. Same story. We had failures reaching to API server, pods restarting. Uh, Even Kyverno and Capsule kind of in a loop. So because we had some mutation rules in the Kyverno and Capsule being when we onboard tenants, it tries to make some changes for the namespaces. So one is getting into the loop into another. So in both cases, we need to figure out a way where those two don't get timeout to the API server. Either they get some kind of a preferential treatment, which we're going to discuss. I'll show you. That's called flow schemas. We'll bump up the priority for specific calls. We'll get into that. But otherwise, the issue was not limited to the capsule, or it's not an issue with the API server as well. Because if we directly reach over to the API server, it gets the response pretty quickly. Meaning not all API calls which are made by the Capsule or Kyverno we're actually getting timed out. But those calls might not be urgent as the leader election calls. So that's the next step we are going to see now. I just want to show here that some regular API calls work, but something's very specific about leader election is failing. It's time to look into the other pieces. Okay. So the so far the what we have seen is there are too many requests, some getting timed out, some not. It's a random behavior. Before I get into the flow schemas part, I want to discuss about something called as API priority and fairness. APF, I mean, shortly we can call it as APF. So APF is a built-in K8 feature, Kubernetes feature designed to protect the API server from being overwhelmed. Think of it as a traffic management for your cluster control plane. Here is how it works is every request to the Kubernetes API server gets classified into a flow schema. We'll get to that, but flow schema. Based on that, uh, it gets who is making the request and what they are requesting. Each flow schema is assigned to a priority level. For example, there are it has either workload high, workload low, or leadership elections. Think that has different swim lines. One gets more priority, one gets lower. So these priority levels have different concurrency limits and queue sizes. The high priority one gets more resources, obviously, and shorter wait times, and the lower priority ones gets either too slow throttled or limit. It gets just rejected by default. The service account requests that's what the Capsule or Kyverno use go through catch-all flow schema. Now, what it means with the catch-all flow schema is I'll show you in a bit. So think as if it is a rule, like an email rule or Gmail rule, which catches all the emails. In similar way, sorry, yeah. So uh, we'll discuss a little about the individual fields here, but what we can see here is it catches all the pieces of a service accounts. I mean, it's a catch-all flow schema which captures all the service account requests, and they are assigned to workload low. So back to the diagram, if you see, if it is workload low, what it actually means is either it gets long waiting time or it gets rejected. This explains better, I think. If you see the incoming request, either it's a capsule, a Kyverno, the flow schema which I was showing just now, this thing, this is as like a very catch-all Outlook rule which catches all the mails. It catches all the requests made by these components, and by default it puts them into a bucket called workload low, because this has been set as workload low here. The problem with that is you cannot treat all the calls made by Capsule or say for example Kyverno as one, because there are few calls which are leadership election related. So if those gets throttled or rejected, the component, I mean the capsule or the component controller pods will also get affected, and obviously it gets restarted. And God forbid, if capsule and Kyverno are in a loop, it could cause a serious issues in the cluster. So underload, I was explaining, underload, it gets either timed out or throttled. So now it's time to add or find a way if we can prioritize a specific calls which a capsule or Kyverno or some controller makes, so that we can let at least the leader election calls to move forward. That's where uh, we have we need to create a specific flow schema. So a typical leader election uh, specifically or uses three types of resource actually. One is it looks for the endpoints, it looks for the config maps, or it looks for the leases. So if we can put uh, them into the other rules, like it's like a normal Outlook rule. If you put them into the rules, saying that okay, these calls, the calls which are made towards the config map secrets, this is the flow schema, it is going to catch it uh, and bump the priority order. That should help actually. So that was the reason we have created a new flow schema for leader election calls. So if you see the schema part here, the first one is matching precedence. If you see, we have given as 220. This is evaluated before the service accounts. For example, if you go back and see the service account here, it is 9,000. So more the number, it's low the priority. So it has got a less number. So this is treated first. This is evaluated first. Lower numbers are evaluated first. So that's where we mention, that's where we need to provide what is your order. Uh, then the other part is priority level configuration, and we have given as leader election. So we are using a dedicated leader election priority level. It's not a general high priority because this is very specifically designed, added for this specific use case where we want to allow only a leader election API calls to bump up and go on a higher order. And the rules. This is a part where we want to match the incoming API calls. And if you see in the rules for this dedicated flow schema, we have tried to add or pick up only endpoints and config map in the core API and leases, and only the verbs needed are get create update. Everything else from the capsule proxy, like webhook, regular API calls, it's not necessarily the capsule proxy, but any controller API calls. It can be any controller web calls, regular API calls, validations. Will continue with the default API flow schema. Here we have done for the capsule, but we can easily clone for the uh, Kyverno flow schema as well. So that's why it has been very targeted here for the capsule. And the subjects, the last part, we match all the service accounts in the capsule system namespace. We also let's apply it. So this is what I want to create. Okay. Capsule leader election by user. Okay. Okay. I forgot to. I think I forgot to tell the user uh, distinguish method. So, for example, this is mostly used for the grouping of the calls. If you want to group, how do you distinguish the incoming calls? Either you want to do with the users or the namespaces. Namespaces. So the only two options possible there. Let's see the status as well. Haven't checked the status. Okay, get. Okay, looks okay. Okay, this looks okay. Okay, so okay, even I got confused when I have created this flow schema previously. So if you see here, the status is false. Usually, when we see the false, we think something is odd with the deployment. It didn't went through, but the way we should see is the dangling is false. So it means that it found the priority level configuration properly. I mean, basically, flow schema is active and working. It just says the dangling is false. So this flow schema has made through. Now, as this has been made through, now we need to check whether the timeout errors are still there. Okay, let me check. So far we are not seeing any errors. Previously, when we didn't had this flow schema, we had a lot many regular errors saying it can't elect any leader. So it looks all good now. The reason being we have added the flow schema, which made a leader election API calls go through with a higher priority, and leader has been selected. So that's that all looks good. Now let's validate with the metrics as well. So before that, to summarize, to see the flow, before we added the flow schema, it's all catch all, everything was put into the priority low. And after priority, sorry, after we added the flow schema, leader election endpoints matched because our flow schema is the one flow schema service accounts. Yeah, this one. So this only matched with the endpoints, lease and config maps. So this all looks good. So this new flow schema which we added, match, it gets high priority. Anything else, back to the same old catch-all service account flow schema gets the low priority. So this is the difference between when we add before flow schema and the after flow schema. Now it's time to uh, check whether it how in terms of metrics how it actually impact. Actually, there's a next thing we all should do. So the three metrics which we need to observe, or the main metrics which we need to see with respect to this case is API server flow control rejected request total. Basically, what it means is how many uh, how many requests were rejected. This is one. How many requests were rejected, and whether it is a long wait time, it's getting throttled, or it's waiting time, and is how what's the queue, whether it's a priority low queue or high queue. So this query, I think it's clear. Uh, this is from another cluster, but the same flow schema we applied for the previous cluster, which I did the live now. So there, what we have observed was soon after the flow schema, the priority flow schema which we added for the leader election, the one part is might not we might not see the entire calls getting down, because this is very specific to capsule leader election. So we did see a dip. The query which you are seeing is the rate for the 5 minutes. So if there are any rejection, if there is any uh, change in the rejection of the API calls for the flow schema service accounts. Oh, where's the, I think there should be another query I need to look. But basically, this says the flow schema is service account, but our flow schema is a leader election. It should be somewhere down. But fortunately, we also seen there is a dip in overall rejected rates, but not necessarily with the linked with the leader election part. In general, the dip is already seen. Oh, we also see it. Sorry. I think this, yeah, this can be a good one. So here we are summing up the uh, what to say, the rejection. Oh, okay. So sorry, this is also flow schema for the service account. But you overall we have seen the dip in the rejection request total, and we already seen in the logs the leader has been elected properly, and there is no leader election failures. But for the if you want to check the metrics, these are the metrics we would want to see. Sorry, the flow schema, rejection rates, and the overall requests. Overall request when compared to the rejection rates in whole as a whole. So to sum it up, I just want to plan a short video on this, but the overall summary, what I want to show, I want to say is we have we so once we saw our capsule pods were constantly restarting, we have checked the logs, identified the symptoms. It's intermittent. It's not happening every time. The leader election, obviously, it's not happening on every time. Either we might have added the uh, the capsule components were rescheduled to some. Sorry, for some reason at the start of the capsule. The leaders will try to whenever the leader election happens, it's getting timed out. That was the issue with the capsule, one of the shared cluster. The paths what we have checked is, the first part is to check the metrics with the flow schema. Previously was service accounts, and when we added with the flow schema, we need to check for the leader elections schema as well. And what's the final? Yeah. So check whether the rate has been reduced, and after that, this was previously we have checked the rate was still constantly rejected. So then that's where we have added the flow schema, and later we have seen The pods were stopped. There were no more restarting and no more timeout errors. And the metric flattens. I didn't added the screenshot where it flattens. It happened for the another cluster. But the capsule were all good. The status dangling is false. It means that the flow schema is made through. And finally, we have fixed our capsule pods restart issue. Yeah, hope this has helped. Thanks so much for watching my first video. I am excited to be starting this channel and sharing tech content with you. If you found this helpful, please watch out this space. I am planning to post bi-weekly or monthly. So please stay tuned for more. Thanks again. I'll see you in the next one.